Back in 2013, scientists were puzzled by a mysterious mass of water in the northeast Pacific Ocean, which was later to be known as the Blob. The Blob was an unusually warm patch of water that had never been seen at that scale before, and it ended up completely frying coastal marine ecosystems from Alaska all the way to California. This strange event wreaked havoc on marine animals up and down the west coast of America. Seabirds died in their thousands, and algal blooms poisoned marine mammals and shellfish. It even caused range shifts for other marine species who started popping up in areas where they'd never been seen before. Ocean sunfish were being spotted in Alaska, and highly venomous yellow-bellied sea snakes started washing up on beaches in California. Over the space of 3 years until late 2016, the Blob drastically altered the marine environment, and some of these changes are still evident today in 2024. But all the while this strange marine phenomenon was happening, a lone salmon shark was out collecting oceanic data on behalf of scientists. The just under 2-meter long salmon shark tagged in Alaska traveled nearly 1,000 miles along the North American continental shelf, straight towards the Blob. For over a year, the shark sent back data that was vital for scientists to learn more about this mysterious marine anomaly. But what did it find out? Scientists have been sticking tags on marine animals for a very, very long time, and sharks are no exception to that. Since the first satellite tag was slapped on a basking shark dorsal fin in 1982, which was the first ever fish to be satellite tagged, by the way, we've come on quite a way since then. And we've learned so much about how these animals live their lives, their migrations, their behavior, even how fast they can swim. We've put satellite tags on them, acoustic tags on them, tags that can communicate with other tagged sharks. We've even managed to put camera tags on them that gives us sneak peeks into what sharks do and how they behave when we lose sight of them beneath the waves. But one type of tag is not often used on shark species, and that's known as a CTD tag. CTD stands for conductivity, temperature, and depth, and it's a type of satellite tag that records oceanic environmental data. You can probably guess pretty quickly two of the types of data that it collects, and that's temperature and depth, but it also collects data on salinity, how salty or not salty the water is. These are three really important environmental variables for understanding how the ocean works, and in particular helps us understand marine anomalies, things that sometimes we scientists struggle to explain. Scientists have been measuring ocean variables for so many years, trying to learn as much as they can about the ocean, but normally they'll be using mechanical devices called profiling floats. You might have seen them before. They usually look like this: cylindrical devices, often yellow in color, that are plopped in the ocean, and then they drift around and send their data back to satellites. It's known as the Argo program. As of 2018, we had nearly 4,000 of these devices scattered across the world in lots of different oceans, continuously reporting back on their findings. They're helping scientists understand more about oceanic currents, and it's particularly useful for helping us understand how the climate is changing across all of our oceans. Since the year 2000, we've collected more oceanic data using these devices than the previous 100 years combined, which is pretty impressive. But despite this massive amount of data that's been collected so far, there are still some areas that we don't have much data for, namely along the coasts and in the polar regions. Understanding both of these regions is so important. We need to have information about the coasts because that's where we humans live, and it's where lots of marine species live as well. And we need to have information about the polar regions because it's likely that these areas are going to be the most drastically impacted by a changing climate. As of currently, CTD tags have been used mostly on elephant seals, both in the northern and southern hemispheres, and this is helping scientists fill in some of those gaps, both in the Arctic and the Antarctic. But elephant seals are a marine mammal. They have to come up to breathe air, and they spend a decent portion of their lives on dry land, squashing penguins and slapping into each other. Look at the size of him. Damn, boy, he's thick. I love elephant seals. Anyway, because elephant seals spend a decent portion of their time on dry land, it means that scientists using those CTD tags on them aren't getting that continuous stream of in-water oceanic data. So some scientists decided to try a different kind of marine animal, one that spends all of its time in the water and travels decent distances across the ocean. What better candidate than a shark? But there aren't many shark species that venture into the polar regions that can be easily captured, tagged, and tracked. You've of course got the Greenland shark, but they're a little bit slow. Sorry, Greenland sharks. You've got spiny dogfish, but those guys are a little bit too small to be fitted with a CTD tag. And then also you've got your six gills and your Pacific sleeper sharks, but they're spending a lot of their time in the very deep ocean, and that's not going to work because you need that satellite tag antenna to be popping out of the water to send the signal to the satellite. But one of the best candidates of them all is, of course, the salmon shark. This medium-sized cold water shark, who is a pretty close relative of the great white shark, was the perfect species to fit with the CTD tag. The scientists still had to tweak the tag to ensure that it was small enough to not hamper the salmon shark, but also it had to be long enough to get the antenna out of the water to ensure that data could be sent to those satellites. So in 2014, after redesigning the CTD tag, they slapped it on a salmon shark measuring just under 2 meters long in Port Gravina, Alaska. The shark traveled nearly 1,000 miles down the coast of British Columbia towards Kung Hit Island, almost slap bang into the marine anomaly, the Blob. Not to be confused, of course, with the bloop, which was that weird noise they heard in the South Pacific in 1997. Do not get me started on that mystery. Also, slight side note here, I'm pretty sure marine scientists are all just having a laugh with each other when they decide to name some of these things. The Blob, the bloop, they're just taking the piss. Anyway, back on topic. A year before this lone salmon shark was tagged, the Blob had been noticed by scientists, although at that point it wasn't really causing too much damage. A high pressure ridge in the eastern Pacific Ocean meant that normal winter winds had been reduced dramatically, and without these winter winds, the sun warmed the sea surface into an ever-expanding hotspot. By the time the salmon shark had been tagged and released with its CTD tag in 2014, the blob had got bigger, spreading up and down the west coast of the North American continent, and this brave salmon shark had just swum right into the middle of it. If you're admiring the bravery of this salmon shark, by the way, and the loudness of today's summer shirt that I'm wearing, make sure you hit that like button. Anyway, the data coming back from the shark was extraordinary. Massive temperature shifts of 3 degrees Celsius above the average were being reported between 20 to 45 meters from the surface. As the shark moved further south, the salinity of the water got stronger and stronger and extended down to 75 meters below the surface. The data collected from the shark was being compared to the data collected by the Argo profiling floats, and it turned out the shark was collecting more fine-scale data than those floats. The scientists were learning about the blob in greater detail because of this salmon shark, but by having both the profiling floats and the salmon shark, they were getting data that was being supported by the others' findings. It was being corroborated. The data that they got began to confirm their fears. The blob was getting bigger, and with an El Nino developing alongside it, it was only going to get hotter. And that's exactly what happened. By 2015, the blob had engulfed the entire west coast of North America. Algal blooms began choking the ocean of its oxygen, seabirds started dying off, California sea lions were dying, whales were stranding on beaches, and a lot of Pacific fisheries ended up collapsing. The pink salmon fishery in Washington was destroyed, and the Californian sardine fishery went under as well. It was truly devastating for the marine environment, but the salmon shark had given the scientists the extraordinary data they needed to start trying to understand this bizarre marine heat wave, and to warn people that events like the blob might start to become more common, which is exactly what happened again in 2019 and 2020. Admittedly a bit smaller than the first, but it still caused quite a bit of damage. The combined data that we had from the salmon shark alongside the Argo floats allowed the scientists to understand the fine-scale changes caused by the blob, which eventually helped them understand why it might be happening. Climate change undoubtedly has played a role, but interestingly, an environmental policy designed to reduce air pollution possibly played a role as well. And yes, I did say there, a policy designed to reduce air pollution. A steep decline in aerosols emitted by factories since 2010 actually might have amplified these marine heat waves, or blobs, in the Pacific Ocean. Aerosols can act almost like tiny mirrors, reflecting sunlight back into space, which reduces the amount of sunlight that actually reaches the Earth's surface. It is important to point out here that the reduction in aerosols didn't cause the marine heat waves, but they likely amplified the intensity of them by quite a bit. But it is possible that it's a combination of climate change making these extreme events easier to happen, and the reduction of aerosols increasing the intensity of them. It's perhaps a cautionary tale for those out there who have suggested that we start injecting aerosols high into the atmosphere to try and cool the planet. We know from the blob that the climate can respond quickly to changes, with strange and unexpected repercussions happening oceans away. For the salmon sharks though, their potential for becoming one of the best species to monitor the polar oceans is high. The study showed they could easily and widely be used as oceanic observing platforms, OOPs. Oops. See, I told you, the scientists are taking the piss with how they name things. Anyway, one of the authors of that study, Barbara Block, released a different study a few years back known as the TOPP project, or TOP project, which stands for Tagging of Pacific Predators. It was one of the biggest studies ever undertaken and involved the satellite tracking of 22 different Pacific predators, with more than 2,000 animals tagged. Within that study, they tagged a number of salmon sharks in the eastern Pacific Ocean from 2002 to 2019. And if, in that study, they had attached these CTD tags to the salmon sharks, they would have been able to collect double the amount of data that the Argo profiling floats were able to collect in the same time frame in this part of the world. Double the amount of data. That's a lot of oceanic data there that could be used by scientists to help us understand the ocean and how it works. And it just shows how much potential these sharks have for helping scientists learn more about the ocean, especially in the polar and coastal regions. But it doesn't stop there. If these tags can be applied to different shark species who are capable of bearing that tag, we could eventually have a whole fleet of literal shark scientists across all the different oceans.
Yes, science!
The scientist in me is totally geeking out at all this potential data that we could have. I am such a nerd. Shark tagging though, or biologging as we call it, is so important, not only for helping us understand more about these specific animals, but also about the ocean as well. One species in particular though that we've learned so much about because of satellite tags is the basking shark. I mentioned earlier that the first ever marine satellite tag attached to a fish was that of a basking shark, all the way back in 1982. And in this video right here, you can hear all about it. There's some insane tagging stuff in this video. There's even footage of a basking shark breaching out of the water while wearing a camera tag. It's ridiculous. So if you wanted to watch that video and learn a bit more about basking sharks, give it a click here.